channel. I am Theresa and I am a data scientist here in Germany. In today's video, we are going to talk about commonly used machine learning algorithm and when to use them. This video is only for beginners and I am only going to discuss the overview. So topics such as what is machine learning, why use machine learning compared to regular programming, and what are the types of machine learning, the common algorithms under these types, and when to use them. So what is machine learning? Machine learning is a branch of AI or artificial intelligence that is based on the idea that systems can learn through data and patterns that gives decisions with minimal human intervention. So you can think of these systems as a child. So in order for them to learn, they have to have experiences, and these experiences will help them give decisions on their own. For example, for a child to know the difference between an apple and an orange, you as an adult have to show the child what oranges look like and what apples look like. And this process is like training them on identifying what oranges are and what apples are. So machine learning works like that. It learns from the data that you feed them, and through training it with this data, they will be able to identify or predict an outcome with minimal human intervention. Applications of machine learning in our daily lives include weather prediction apps or your Netflix recommendation or anything recommendation system. So why use machine learning compared to regular programming? Let's take, for example, if we want to categorize an email, if it's a spam or not. So in this example, in this email, we can see all suspicious headings. All of them are in capital letters, and also there are some trigger words like charity purpose for the needy. And here in the underline word, you can see return, which is all caps in the content, which is not very normal if you're writing a formal or normal letter. And also it involves very big amount of money, like $5.5 million dollars. And then the overall content of the email is really very suspicious. So if we want to categorize this email as a spam using an explicit programming, we have to make a lot of rules for this. I would imagine a regex rules, just making a rule that if there is a capital words in the content or there's a mention of big amounts in the content, then categorize as a spam. And if the headers are, you have to make all these trigger words like need, help, or lose weight immediately, or free 100%. You have to make these rules just to, have them categorized as spam, which is so manual, and over time it will produce very complex rules. And if spammers change their method to spam you, then you as a programmer will also add additional rule to what you already have. And in the long run, it will become very complex and it's not maintainable. So it's not a pretty smart way to categorize an email if it's a spam or not. Whereas if you use machine learning will automatically detect the spam by detecting unusual patterns in the words based on the training data that you have. So you will have, millions of data, and it's already categorized, like those patterns are already categorized, spam or not. So the machine learning method can easily detect this, and the code will be maintainable, it's scalable, simple, and it is also more accurate compared to the regex rules that you have. So this is just an example of why in some situations we have to use machine learning compared to the regular programming. So what are the types of machine learning systems? There are three main types of machine learning. So we have the supervised machine learning, and then we have the unsupervised machine learning, and we also have the reinforcement learning. But in this video, for the simplicity of the topic, I am only going to discuss about supervised machine learning and unsupervised machine learning. So let's start discussing about the supervised machine learning. Supervised machine learning, this is a type of machine learning that is trained on the data that already has answers to it, or called labels. So there are two tasks of supervised machine learning. One is a classification task, and the other one is a regression task. So a classification task is when you predict a class. So a class, example of a class is that if you want to predict if it's a cat or a dog, if it's a cancer or not cancer, or a spam or not spam. These are example of the class, so it's not numeric. Whereas regression task, you are predicting numeric values. So for example, predict the house price, or predict the sales, or predict the temperature. So these are all numeric values. So examples of the algorithms for supervised machine learning, these are the very common ones. So we have linear algebra, we have logistic regression, and we have the random forest algorithms. So in reality, there are a lot more than that, but in today's video, I'm just going to discuss these three in general level. Let's start on linear regression. So linear regression, this is an algorithm that establishes a relationship between variables. So for example, based on the variable height, predict the weight of the person. So linear regression is used for regression tasks. So it is predicting numeric values such as, as I've said before, predicting house prices. For example, given the number of rooms of the house, given the floor area of the house, given the size of the house, predict its price. So that is where linear regression is used for. The second algorithm is logistic regression. So even though it has a regression in its name, it is used for classification. It is used to estimate discrete values like 0 or 1, yes or no, true or false, based on the independent set of variables. So in other words, it predicts the probability of an instance belonging to a class. So in this picture, you can see the logistic function, and how we interpret this is that, for example, given the different characteristics of a tumor, its mass size, form, the texture, predict if it's cancerous or not cancerous. So in this sigmoid function, there is this decision boundary where if it's greater than or equal to 50%, it belongs to the class 1. And if it's like lesser than 50%, it belongs to the class 0. So for example, given these tumors, like given these characteristics of tumor, and then we predicted the probability of 70% of it as cancerous, that means since logistic regression is either 0 or 1, and so 70% is greater than 50%, that means it is categorized as 1. So that's logistic regression. So next algorithm under the supervised learning is random forest algorithm. So this algorithm is really powerful. It is commonly used in a lot of data science projects, and it is also used for regression and classification. So random forest is an ensemble method, and in other words, is an algorithm that takes the average of many individual predictors. And these individual predictors in this case are called decision trees. So a group of decision trees is called random forest. So how it works? So you can train a group of decision tree classifiers on different subsets of your training set and get the prediction that has the most vote for example, classification tasks, or get the prediction of the individual trees and average it for regression tasks. For example, in this picture of random forest classification, you can see here that all these pyramid looking are trees, and one tree is called a decision tree, and a group of trees is called the random forest. And if it is a classification task, if one tree predicted a cat, tree 2, for example, predicted a dog, and then tree n predicted a cat again, the algorithm will then take the class that has the most votes. So for example, in this picture, you can see that a lot more trees are predicting for cats rather than dog, and so that the final class or the final prediction would be the cat. For random forest regression, again, we have this individual decision trees. For random forest regression, how it works is that it gets all the prediction of those trees and then average them all. And then the average of all these predictions is then the final prediction. So now let's move on to the unsupervised machine learning. So unsupervised machine learning is the opposite of supervised machine learning. So this means that if in the supervised machine learning, there is a label on the data. Unsupervised doesn't have a label on the data, which means that it has no defined answers, and so it mostly learns on the pattern. Example of algorithms for unsupervised machine learning is the Kmeans. So this is very famous for this type because it's very easy to learn and it is also powerful. So K-means can be used for customer segmentation. So customer segmentation is very important for marketing. If you, for example, want to understand their behavior, you want to understand what they need, who they are. Yeah, so you target your customers using different marketing strategies per segment. So how does K-means works? As you can see in here in this picture, from unlabeled data, we want to cluster them into 3 clusters. So in real world, we really cannot tell how many clusters we want K-means to have. So that's why there are different metrics to use, such as the silhouette score or the elbow method, but that discussion will be in another video. But for now, we will take the simplest form. So how it works is that we have this unlabeled data, and then from this unlabeled data, we will randomly assign cluster centroids. So the cluster centroids in this case are the 3 different axes here, and that is randomly assigned. And K-means is an iterative process. So it has 2 steps. So the first step is the cluster assignment step, where you assign all the points that are closest to the cluster centroid by measuring their distance. So as you can see here, you will go through all the points and calculate their distance to those different cluster or axes. So after you assign them, we will then proceed to the step 2, which is the move centroid step. So where you move the cluster centroid to the average of the data points assigned to the cluster. So as you can see here in the third box, the position of the cluster centroids change. That's because we already moved it based on the average of all the data points that are assigned to them. And this iterative process will continue until there are no data points to be assigned in the cluster centroids and you cannot move the cluster centroids anymore. So in a nutshell, that's how K-means works. So there are also a lot of variation of K-means, and there are also other clustering algorithms, but for now, for the simplicity of this video, I'm only going to discuss K-means, which is the simplest algorithm in the unsupervised machine learning system. So yeah, that's it. It was very simple and it was really the general overview, but I hope that at the end of this video, you will have an idea of what are the common machine learning algorithms, and if someone would tell you about random forest regression, at least you will have this imagination of what random forest looks like. And I know that it's very general, and I think in the next videos I will try to explain it more in details. Yeah, thank you for watching, and I wish you a wonderful day, and please take care. Bye.